Okay, I'm going to continue working through rational exponents, starting with 46 on page 22. I have the fifth root of x to the 10th, which if you keep it in radical form, right, if I'm looking for a fifth root of something, I might recognize that x to the 10th is the fifth power of x squared, okay, which means that this is more simply x squared. Or if I want to use rational exponents, I could say, well, that is x to the 10th over 5, which is also x squared. Then, part B, I have the fourth root of 16x to the 8th. So let's deal with our number first. And this 16 is 4 times 4, which is 2 times 2 times 2 times 2, so that's actually 2 to the 4th. And then this is x squared, also to the 4th. And you can always take 8 and divide by 4. And so now I've got the fourth root of two things that are to the 4th power. So this part is going to be 2, fourth root of 2 to the 4th. And the fourth root of x squared to the 4th is simply x squared. Or you can deal with the number this way. That might be easier. With x to the 8th, right, if that is in a fourth root, then that is x to the 8th to the 1/4, which is x to the 8 over 4, which is also x squared, just as it is down here. And of course you got 2 that goes with it. What about number 48? Let's take a look. We have the fourth root. This is number 48. This is 46. The fourth root of x to the 4th y squared z squared. Again, two ways to handle this. One, I could leave it in radical form and say, well, the fourth root of x to the 4th is x. And then those are going to stay in my fourth root. It's a little bit harder to see, but I could simplify this even further, and that's where rational exponents are even more helpful. I can take what I have inside here, x to the 4th y squared z squared, and say, okay, well, that's to the 1/4 power, which means that I've got x to the 4th to the 1/4, so x to the 1st power. And also I should remember that I want to put that in absolute value brackets because, well, what if x is negative, but then x to the 4th would be positive because it's an even power, and then the fourth root is going to be positive because your root is always a non-negative number. And that's why we have to add the plus minus when we're solving for x, and x could be negative. But if we're looking for the root, that's a positive, or at least non-negative number. Then we have y to the 2 over 4 power and z to the 2 over 4, which actually simplifies both of those to the 1/2 power. Well, what the 1/2 power means is square root. So that's simply the square root of yz. Right? You can almost see, well, hey, 2 out of 4 is halfway up to being 1 full power of y or z, and so that's our answer for 48A. Well, what about B? I've got, for part B, 48B, up here, 48, I have the cube root of the square root of 64x to the 6th. Oops. X to the 6th. Made my x look like an exponent. Sorry about that. So again, I can do this two ways. Let's do rational exponents first. I have 64x to the 6, the square root of that, and then the cube root of that. Whew. Well, I could work this out first. 1/2 times 1/3 is 1/6. So this is 64x to the 6 to the 1/6 power. 64 is 8 times 8, or 2 cubed times 2 cubed, or 2 to the 6th, 2 to the 6, x to the 6th, to the 1/6. Now you see where this is going. That's 6 times 1 over 6 is 1, so I have 2x as my answer there. Of course, if I work these out one by one, looking at radical form, let's take the square root first, so we'll work from the inside. Square root of 64 is 8. Square root of x to the 6 is x cubed. Since x cubed squared would be x to the 6th, so now I have the cube root of 8x cubed. The cube root of 8 is 2, and the cube root of x cubed is simply x. So either way will work.